inequalities never end. They just get tougher. But don't worry, it's not that bad. We're making it a little bit more complex than our last example, but nothing has changed. If you can follow these 3 steps to success, they work for solving equalities. It's the same steps for solving inequalities. Our process hasn't changed. We've added a rule. If you divide or multiply by a negative number, it's the only thing that's changed. We can do this. First off, I want to simplify each side of the inequality in this case. So can this be simplified? You bet it can, and we're going to do it. After we're done with that, we're going to isolate our variable, then we're going to make a 1 coefficient. So that's all there is to it. Simplify each side. Get rid of those parentheses first. Parentheses must go. Simplification comes in a 2-step process. Remove parentheses, combine like terms. So here we have it. This becomes 2x minus 6 plus 5x. I can simplify continuously, so 2x plus 5x gives me 7x minus 6. My symbol is going to stay the same because I'm not moving anything. All I'm doing is simplifying. Same thing on the right-hand side. I'm going to take that 8, and it's going to give me 8x minus 8. So my next step, I'm just going to carry it right along with me. Now, so I'm all done here. I've simplified. Now I'm going to isolate. I want to isolate my x variable on the left. So to do that, this has got to go to the other side. I'm going to pull it off by subtracting 8x. If I want the variables to land on the left, I'm going to have to make the constants move to the right. Add 6 to both sides, we're going to have it. Here it comes. A negative x is less than or equal to a negative 2. Okay, did I want to know, my goal, I didn't establish it, but I want an x on the left and something on the right. Unfortunately, this has negative x, so how am I going to get rid of the negative? Some people can say they divide by negative 1, or some people can say they multiply by negative 1. It doesn't matter how you do it. Either way, you got to get rid of that negative sign, and if I'm not paying attention, I'm going to cause myself trouble right here, but I'm going to switch my sign right now because I multiplied and divided by a negative value, so that inequality switches. The negative x becomes a positive x, the negative 2 becomes a positive 2, and there is my answer. So I have the set of all x's such that x is greater than or equal to 2 is my solution set. I can put it on a graph. I've got a 2 someplace, and I'm going to be greater than or equal to it. So I'm going to color as such, and in my interval notation coming from the left, I end up with a 2 being the first number colored, coloring to infinity, and use my appropriate inclusion symbols so that the 2 gets to be included and the infinity does not.